All right, we're going to take a look at exponential equations. And the thing to remember about the word equation is if you look right here, it has the word almost saying equal, which means it needs an equal sign. All right, so some of you, sometimes you forget to write the actual equation. The equation must have the equal sign. So here we have y equals ab to the x power. And I do want to mention sometimes you do see plus c, something over here. I'm going to explain the whole thing with the plus c. If it's not there, then it's an invisible zero, because if you don't see anything there, what's there? Nothing. So what is that number? Zero. So again, I'm just going to explain what each of these things mean. So you have A. A plus C is the y-intercept. Okay, and like I just explained, that if there's nothing here, it's zero, so therefore A is the intercept. What that means is, and we'll talk about a couple of examples, let's say I had this equation, okay, what would the y-intercept be? Well, it's the letter A plus C. Look at where A is placed and look at where C is placed. A is on the left of the number that's by the exponent. So if you see, this is the exponent, that's the number by the exponent, and this is A. So this is the position A, and this is the position C. To find the y-intercept, you add them together. So 2 plus 2 is 4. Okay, well, let me give you another example. See if you can do this one without me actually doing it. Okay, so what you should have done, it's the same thing. This is A, which is 3. This is C, which is -2. 3 plus -2 is +1. So the y-intercept is +1. Let's do one more just to make sure you're okay. Okay, again, y-intercept is A plus C. So here's A, which is 5, plus here is C, which is nothing. So remember, we said that this is an invisible zero. We just never write it out. So what is 5 plus 0? 5. Okay, so once again, A plus C is your y-intercept. The next thing we're going to look at is this letter B. B is always by the exponent, and it represents growth or decay, and this is very important, factor. Factor just means that you are multiplying. All right, factor just means that you're multiplying. So we're consistent. For it to be exponential, you have to multiply to get to the next thing. That's what it is. So how do I know that this number right here, without me typing it into decimals, is growth, for example? If the factor is greater than 1. So if B is greater than 1, it is growth. How do I know it's decay? If B is between 0 and 1, it is decay. So all you have to do is look at the numbers inside the parentheses. And sometimes, in fact, I'm going to do one that is not inside the parentheses. So let's do 2. Oh, I just did parentheses out of habit. I'm sorry. Multiplied. So that's multiplied, not a decimal. 3 over 2x. So B's placement is right by the exponent. Okay, B's placement is right by the exponent. So let's look at only B. So this is B right here. So B is 3. Is that greater than 1 or between 0 and 1? It's greater than 1. Therefore, this is growth. All right, again, it's 3 right here. So again, the same thing. It's growth. What about 1/2? If you are not sure where 1/2 falls, is it bigger than 1 or between 0 and 1? Then what you can do is you can come into a calculator and you can literally just type it in. So again, it's 1/2, which is 1 divided by 2. So you put a 1. In fact, let me do it with this keypad so you can see 1 divided by 2 is 1/2. And you can see the number that 1/2 is. So again, knowing that 1/2 is 0.5, does that represent growth, which means it's bigger than 1, or decay, which means it's 0 to 1? It represents decay. So this would be decay. Let's take a look at one more. So I have 3 over 2. Again, if you are not sure, you type it into decimals. That's 3 divided by 2. So 3 divided by 2. And look at that number, it's 1.5. So now your question is 1.5 greater than 1 growth or between 0 and 1 decay? So 1.5 is definitely greater than 1, therefore it is growth. So this is showing exponential growth as the factor. And again, the factor is B. So that now explains what A, B, and C is. And the last thing that I need to go over is X. What does X mean? X simply means the time. What is the time that has passed? Whether that's hours, days, minutes, years, it doesn't matter. It just represents the time. Now that I've gone through A, B, X plus C, you now have to apply those questions into questions that you may be asked. The value of a used vehicle in a few years after purchase is given by this equation. So I'm given an equation and this is the value of a used vehicle. Please keep the question in mind. It will change every time. What does 300 represent? Well, let's remember what we talked about. So when you're looking at an exponential function, you're always going to have y is equal to a times b to the power of x, or you could put that in parentheses. A is your y-intercept, b is your growth if it's bigger than 1, your decay if it's between 0 and 1, and your factor, your growth or decay factor, and then x is your time. Given that, now instead of a, b, and x, what do I have in place? I have a function is equal to 3,000, so that's in place of a. I have it's growing or decaying by 0.94. So before I even type this in, is this going to be growing or decaying? Because it's between 0 and 1, it is decay. It is not bigger than 1 growth. So I'm going to, where is it? There you go. And you can see that it is decaying. It is sliding down, going down. All right, so I knew it was going to be decay before we did it. Now that we know that, now I've explained what each of these numbers are. Before I even look at the answer, I'm going to choose what does 300 represent in the exponential equation, given that this is the value of a used vehicle a few years after the purchase. It's what I purchased the car for. So I'm looking for something that says that. So when I click here, the value of the car after 2 years, no, it's what the value of the car was when I got it. The amount that it decreases each year by, no. The value of the car when it was purchased, yes. I'm just going to read the last one. The rate of decay, no. All right, so again, once you understand what A, B, and X are, you can answer any of these questions. What does the 2 represent? Let's see, where's the 2? The 2 is in place of the X, and I forgot to add that in there, so I'm just going to put that in. Not like that. Shift 6 and 2. All right, so the 2 is in place of the X, and X means time. So X is 2, and whatever they say the time is here. So if you read here, it says a few years. So this is 2 years after the car was purchased, because I'm just talking about what's happening in the question. 2 years after the car was purchased. The number of dollars the car loses each year, no. The number of years since the car was purchased, yes. However, I'm going to read through. The rate of growth, no. The total value, no. The only thing that has time is this, and it is the number of years since the car was purchased. Does this exponential equation represent growth or decay? Well, you just look at it. If it's between 0 and 1, it is decay. You can also type it in here, but obviously if you type it in exactly like this, you'll see this. You'd need to change this to an X to see that it's decay. So we're going to say decay, and let me see what the answer choice is. And since the answer choices, I'm looking at, well, how do I know it's a decay? Because it's between 0 and 1. The decay factor is between 0 and 1. Exponential growth, nope. Exponential growth, nope. Exponential decay, because the value decreases by a constant amount of 0.94. No. Decreasing by a constant amount means I'm going to subtract 0.94 each time. Remember, because it's exponential, I am not subtracting, I am multiplying. So I'm looking for that. Exponential decay, because the value is decreasing by a factor, there's that word. Growth and decay, factor. Factor means I'm multiplying by 0.24 each year. Evaluate the exponential equation. So what exponential equation? The one they gave you, they want you to find the answer. So if I type it in, I can see the answer is 2,000, and this is in money, right? The value of a car. So if I write 2,650.8, that does not look like money. Money has 2 places after the decimal. It's 2,650 and 80 cents. So you must write that 0. If I had not typed it in exactly, and let's just say told me evaluate it at a different number, so I didn't know what number it was telling me to evaluate it, I'd make it a table, and I can evaluate it for any number. So 2 is what we just talked about, but I can also evaluate it for 10. So I can come here and type 10, and that's what it is. And again, because it is money, I would not say everything after the decimal. So remember, in another question, I was dealing with the number of people, so I couldn't have decimals. This is money, so I can have decimals, but nothing past the second number. So this 5 would make this go up to 85, for example, if I was rounding, if it's money. Okay. Oh, check my answer. Perfect. The amount of substance can be modeled by this equation, where t represents the time in hours. Does this represent exponential growth or exponential decay? So once again, remember, if it's exponential growth, the factor, which is the one by the exponent, has to be greater than 1. If it's exponential decay, it's between 0 and 1. So if we look at this number right now, is it growth or decay? It's decay. Why? Because it is between 0 and 1. So this is decay. And why is it decay? Because this growth, this decay factor, what I'm multiplying by each time is between 0 and 1. So when I look at it, because the amount increases as t is increasing, no. Because I'm not talking about increasing, I'm talking about exponential decay factor. Because the coefficient of a is multiplied by t, so the coefficient of a, this one, is multiplied by t, no. Because the factor, so here we go, factor is greater than 1. It is not greater than 1. Because the factor is between 0 and 1. Yes, it is. That is why this is exponential decay, because the decay factor is between 0 and 1. When I go to this question, okay, I can't see it, but what I can do is I can type it into decimals. Now, I do know that this is growth because the numerator is greater than the denominator, but let's assume you don't know that. You're going to type it in. So I see 8 divided by 7 as my factor, and you can see it's 1.14. So because the factor, which is again right by the exponent on the left, is greater than 1, this says this is exponential growth. So this is exponential growth because the growth factor is greater than 1. Because the factor is greater than 1. All right, finally, we're going to match this with growth and decay. So all we're looking at is the factor. It's greater than 1, it is growth. 1/2 is 0.5, but if you don't know it, you can again type it into the calculator. So you're going to do 1 divided by 2. You can see it's 0.5, so you know that that is decay. 0.975 is between 0 and 1, so it's decay. 1.03 is greater than 1, so you can see it's growth. 5 divided by 4, the numerator is greater, so this is growth, but you can type it in if you're unsure. 5 divided by 4 is 1.25, so I know it's greater than 1, that is growth. 4/3 is also growth, but again, you can type it in to be sure. 4 divided by 3 is 1.3333, which is greater than 1, therefore it is growth. Find the equation of an exponential function represented by the table before. So because I see this word exponential function, I already know that I'm going to have y is equal to a times b to the power of x and possibly a plus c. But again, most of the times you do not see this plus z. It's usually 0, but sometimes you do see it. Once again, you have to know what each thing is. A plus c is the y-intercept, b is the growth or decay factor, and x is time. Once you understand that, you can write it from a table. So my first question is, what is the y-intercept? Well, the y-intercept is when x is equal to 0. So I think that this equation is going to be 0.1, and I can say times, or I can put this in parentheses. It does not matter. And since I'm here, I'm going to raise it to the power of x or t. If they tell me to use t, they don't. So x. And the only thing I need this to make it an equation, which again, because I know it's supposed to be an equation, I need an equal sign. So that means I need y equals. Okay, and this will be my full equation. So once I have my y-intercept, I just need my final, how is it growing? So how do I determine how it's growing? I did not mention this previously, but I'm going to mention it now. You take your second value and you divide it by your first value of your y. You take your second one divided by the first. So if I look at my second one, it's 0.3, divided by the first one, which is 0.1, which is going to be 3. You can see that it's 3. So my growth factor, how do I know it's growth? When b is greater than 1, it is growth. When B is between 0 and 1, it is decay. So because this is 3, that is greater than 1, it is exponential growth factor. All right, now I'm going to quickly check to make sure that this is correct by clicking settings table and now going to match 0, 1, 2, 3, and you can see that it matches perfectly. Another way that I can see what my B is, which is basically what I did, it's a little bit easier to see it from now, is asking yourself, how do you go from one thing to another? From 0.1 to 0.3, 0.3 to 0.9, 0.9 to 2.7. Just ignore the decimal for a second. How do I go from 1, 3, 9, and 27? What am I doing each time? I am multiplying by 3, which is that growth factor that we got right here for 3. Sometimes with decay, it's a little bit harder to see because it's in fractions. So we find that value by taking the second y value divided by the first y value. Now, that's how you do it with looking at it. A lot of questions are very simple just by looking at it. If you find yourself struggling, we are also going to do it via the table. And how do I do that? I input the table and I copy exactly what the table says. Okay, now keep in mind how long this is taking me. I can identify this is my y-intercept right here, which is this, and it's changing by multiplying by 3. I have my function. Here, you're waiting for me to type in the table. I know this is an exponential function, so I'm going to come to the flag. This is a linear. I'm going to press zoom fit right here. You can see does not go through the dots, therefore this is not the representation of these dots. The other one that we've done is quadratic, so I'm going to click that. Sometimes it looks like it goes through quadratic, but you can zoom in further to make sure that it doesn't go, but this one isn't very close. So you can see that it does not go through all the dots, therefore it is not quadratic, but we know it's exponential because the question tells us, and here is exponential. How do I know it's exponential? Because it goes through each of these dots. How do I know from the table it's exponential? Because I'm multiplying by 3. It has an exponential growth factor of 3 every single time. These dots right here represent the solutions to this exponential function. So here's your equation right here, and I can just copy it like that, and there it is that I have it, the exact same thing that I had previously. So whether you're doing it by looking at the table, you are doing it by typing into decimals, I'm okay with both. However, just know that the table is faster. A streaming service tracks the number of active subscribers on the platform each year. The results are shown as an exponential table. So if they tell you it's exponential, it is exponential. Below, complete the table below. So I have years since tracking began and the number of restaurants. And there's a hint here that says, remember that you cannot have a decimal of a person. So create the table. So I know this is exponential. 2 ways I can do this. I can do this by hand. I know that it's equal to y equals a times b to the power of x, where a, right, a is your initial, so where my initial is, and I don't have that initial value. I could find it, but actually I'll do it. To find my b value, I take the second divided by the first, so second divided by the first, so 1250 divided by the first, which is 1000. So I can see my b is 1.25. And if I know that it's growing or multiplying by 1.25, so if I do 1250 times 1.25, I get 3. If I do it again, I get 4, and so forth. If I want to go backwards, I just say instead of multiplying by 1.25, I'm going to divide by 1.25. So starting at 1000, if I divide that by 1.25, that's going to give me my A. So my start, again, remember it's a times b to the power shift 6x. So my start is going to be 800, and we're going to confirm this. I know my b is 1.25, and if I make this a table, it'll match 1 and 2 for this. So you can see that 1 is 1000, 2 is 1250. But again, if you did not understand what I was doing there right there, it's okay. You can use the calculator by just putting in the table with this plus sign, table, and type in the table as you see. Do not make up anything else, because if you are doing it the decimal way, you're just typing what you see. There's my table. I know it's exponential because the question tells me, so I'm going to hit flag, and then I'm going to hit exponential, zoom fit it. Oh, actually, I don't even need to zoom fit it, but there's the exponential function, and now I'm going to answer this question. So what is the number of restaurants when the years is 6? So I need to put 6, but I can't put 6 here because if I put 6 here, it's not going to give me anything because that's me inputting it. So what I have to tell the calculator is, hey, use this equation. So by clicking this, it copies the equation, make it a table. All right, and then I can put in 6, 10, and 19. So if I put in 6, this is my answer. If I put in 10, this is my answer. And if I put in 19, this is my answer. However, be very careful to make sure you read the question. A streaming service tracks the number of active subscribers. Who are subscribers? People. And that's why it says hint. Remember that you cannot have a decimal of a person. So I cannot have 3,051.7578 subscribers. That doesn't exist. I also cannot round up because this, if I round up, will say I have 3,052 subscribers, which I don't. So right now at 6, I have 3,051 subscribers. I cannot round it because of what the question is. Sometimes you'll round it depending on the question, but right now I cannot round it because of the question. In this case, when I have 10 years, when I'm tracking it, I have 7,450 because I cannot have 0.5 of a person. I cannot use this 0.5 of a person and say that I have a full person and round it up. So I must use what I currently have, which is 7,450. On 19 as well, I cannot use anything past the decimal. So I have 55,511. I don't know how, if you're checking your answers, how does it tell you if you're right? Okay, boom, I'm right. The population in Atlanta is given by this equation where t equals 0 represents the population in the year 2022. So this one, instead of saying after 2 years, after 3 years, they're giving you the year. All right, find the population in Atlanta, Georgia in the year 2032. Now, I did give you this hint this time, but of course I'm not going to be giving it to you after this. How do I know how many years have passed? Well, if I start in 2022 and go to 2032, that's 10 years. But if I was doing it with a calculator, I could just subtract the 2. So 10 years. So time is 10. Find the population. So if it gives me this function, here's the function. I'm copying it exactly as I see it. You can say times or you can put parentheses. They are both the same thing. I know it's growing. How do I know it's growing? Because this is greater than 1. The growth factor is greater than 1. Oops. All right, then shift 6 to the power of x, or you can just type it in here. All right, so this is what it is, and I want my time to be 10. Now, I could just type in the time, but because I see that it's asking me a whole bunch of questions with this, I'm going to make it a table. Make it a table. This is what it is, and I'm interested in what does 10 look like. So here is 10. Now, I got to read the context of the problem to see what they're asking. So it's just what is the population? So population doesn't really talk about individual people. You'll never hear the population is 5,856.6 people. Like you'll never hear the decimals because they just want to know the populations. And sometimes they round it differently. So we're going to look at the answer choices and see what we got. So at 10 years, it should be 599,996. I don't see that answer choice. So it looks like since these are all thousands and they all end in 00s, they round it to the nearest thousand. So if I take 996 and round that, it's going to make this 599,000 go up by 1. And that means that's going to be 600,000. Okay, so you could also type it into the calculator, type the word round, parentheses, the number that you want, which is this, Control C, Control V, comma, and how you want it to round. So if I round 1, you can see it took, what did it do? Nothing. Let's see, 2, nothing, 3, nothing, because there are no decimals. So what you have to do is go the other way. So -1, and you can see that's doing that. Okay, so if you're going 1, 2, 3, 4, you means you want one number after the decimal, 2 numbers after the decimal, 3 numbers after the decimal, and then if you go backwards, you're going in the opposite direction. Find the population in 2027. Again, let's assume I didn't know this is 5 years later because I gave you the hint, but I will no longer be giving it to you. I start in 2032, and now it's the year 2027. How many years have passed? 5. So I care about when the time is equal to 5. It depends how the question wants you to round, but if it's doing anything like this, it wants to round to the nearest thousand with a D, not thousandth with a TH. So I'm looking for something that's, if I round this 500, that's going to make it go up by 1. So 556,000. Or you can just look for the closest number if you're not sure how to round. And you can see the closest number is going to be that one. All right, find the population in Georgia when the population in Georgia will be 600,000. You can write the year as the number of years. Okay, so what year is it going to be 600,000? So I'm looking for this part right here to be 600. So I'm going to press enter and you can see nothing happens, right? That's because I've changed the table. So I'm going to go back to where I hadn't changed it. And then I'm going to press enter. See, now I can get a value. And so I'm looking for 600 with these three numbers. 600, 600, 600. Oops, 600, 600, 600. Okay, that's pretty doggone close. If I press enter, that's 610-ish, right? 609. So this is it. So 10 years later, it's going to be 600,000. And remember, this is not asking you really so much how many years, but the year. So it's going to be how long? 10 years later. So if I started in 2022, right, and I add 10 years to that, it's going to be 2022. Sorry. And I add 10 years, that's going to be 2032. So the answer is 10 years or in 2032. So 2032 or after 10 years. So again, this after 10 years is going to disappear because now I've done this question. Caden says the population in 2022, and given that we started in 22, so it's really my starting population. He's saying my starting population is this number. Well, that's not true because I can see my starting population is this. And if I didn't know that, I could definitely, of course, make this a table. I just need to change this into an X because it says, oh, what, try adding Y equals, because I deleted it by mistake. All right, yep, that's all I needed. So settings, table, and I can see that I start at 514457, not 522431. So I do not agree. So do not agree. And why don't I agree? Because my starting population is supposed to be 514,457. So that's what I'm looking for. Because the population increases, no. Because 5222431 is the population after 1 year. So yes, that is the population after 1 year, but I don't care about that because we're talking about whether I agree about 2022, which is the beginning. T equals 0, the beginning. All right, because 514457 represents population with T equals 0, which is 2022, correct. Because the model represents exponential decay. Nobody cares about that because, again, we're talking about what is a population in Atlanta in the beginning. So this reason. Now that you know a table, you can do different representations. And the way that you do different representations is you make it look like a table. If you notice when you input a table, you see an X value and a Y value. Well, how can I get an X value and a Y value that is on this graph? By looking at it, by finding a corner. Let me quickly explain what a corner is. If you notice, this graph is full of these little squares. At the edges of those little squares, right here, right here, right here, right here, are where two lines meet, and that is what I refer to as a corner. So as I move my mouse, and you're going to go ahead and try and see if you find the first corner, the same one that I do. As I move my mouse, I'm going to look for when does this curve click a corner. And you can see, like, even if I stop right here, this is not a corner. If you look at this box right here, this would be a corner, that would be a corner, this would be a corner, this would be a corner. So this graph does not go through one of those corners. I'm going to keep going. Boom. That is my first corner. So I'm going to mark a dot by my first corner. Once I've marked that dot, what I am looking for is to understand I need an X value, and an X value is found by looking down here, left to right, and a Y value. The Y value is found from looking at this axis up and down. So this is the corner that I found. And what I want to do is go straight up and down to find where I hit the x-axis. So in this case, I'm going to go down. What number is this? 0. So it hits the x-axis at 0 in terms of this coordinate. And the y value at this point is when does it hit the y? And I don't need to move because it's hitting the y right now, which is at 1. So the coordinate 0, 1, both of them have to be true, not just half, is this coordinate, 0, then 1. All right, pause the video and see if you can find the next corner. So I'm going to go over and I'm going to stop at another corner, which is this right here. So this point right here. And again, I need what is the x coordinate, what is the y coordinate. So looking at the x coordinate, I come straight down. That is 1 away. So that's going to be 1. Looking at the y coordinate, that's going to be 1, 2. So I put 2. So you only need 2 points to be able to make this into an exponential function. However, I am going to practice a little bit more. So pause the video, see if you can find the very next corner. So again, I follow the line. This is not a corner right here. This is, and this is. Keep going right here. So I'm going to put a dot right there. And again, I want the x value of that dot, which is down here, which is 2. And the y value of this dot, which I go right across, which is 4. 1, 2, 3, 4. So that is yet another point. And what you want to do is plot just a few points to make sure that you're doing this correctly and you didn't pick a wrong point. So I'll do one more again, pause the video, find the next point. So I'm going to follow the line. That's not a corner, that's not a corner, that's not a corner. This is a corner, so here's my next dot. All right, that x value coming straight down is 3. 1, 2, 3. And then my y value at that point is going across is right here. So 1, 2, 3, 4, 5, 6, 7, 8. So that is 8. You will notice that there are dots that are being plotted, the same dots that I'm plotting right here. So you want to make sure that your graph matches on your calculator as it does right here. To see if it does, you're just going to zoom fit it real quick so that you can see all your points. You're going to choose the function that you think it is. So I know this is exponential, but I'm going to go through all of them. Let's say I thought it was linear. Okay, you can see that it does not touch any of my points. So you're looking for what perfectly goes through my points. The other one that we did last semester is quadratic. And sometimes it can look like it goes through the points, but if you zoom in just a little bit further, you can see clearly that it's not touching all of the points. It must be all of the points. So I'm going to zoom fit it again. And the last one we're dealing with this semester is an exponential function. And you can see that it perfectly fits in. Even if I zoom in all the way, you will see that that dot is on the graph. I'm going to zoom fit again. So once again, these points here are solutions to my exponential functions. Why? Because they lie on the graph. Okay, so I have copied this graph onto my Desmos. So that's what I said. You're going to have different representations. If you can make it a table, you can know the function. What is the function? Right here where it says equation, you'll use either the word equation or function. I can copy it onto this next line for me to see it a little bit better. So this is my function. Now I'm going to remind you once again how to do that by hand. So remember, your function is equal to a, b, x, and sometimes there's a c. What is a? Your y-intercept, so that's when x equals 0, so that's 1. So y equals 1 times, what is b? How it's growing each time. So to find how it's growing each time, I'm going to do y2 divided by y1, which is 2 divided by 1, which is 2. So it's growing by 2. And how can I see that? Because I'm multiplying by 2 every time. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So I'm multiplying by a growth factor of 2. How do I know it's growth? Because 2 is greater than 1, which means it's growth. So 2 to the power of x. And you can see that that matches this equation right here. Again, looking at it is much faster than having to type it in. However, I'm okay with you typing it in. If you are just looking at it, since you are given a calculator, you can check your answer. So how do I check my answer? I type in whatever I think it is, which is this. I can do two things. I can make it a table, or I can just look at the graph. I think it's easier to make it a table and just compare your coordinates. So I'm looking for 0, 1. So I have that right here. 1, 2, 1, 2, 2, 4, 2, 4, 3, 8, 3, 8. Okay, so again, if you are doing it by looking at it, please just type it into the calculator just to confirm. So we've looked at how to write an exponential function from a table, from a graph, and here we have from coordinates. All of this is the same thing. Remember, if I can make it a table, it is by far the fastest way to do it. How do I make coordinates a table? By realizing that the coordinate is made out of an x value and a y value, an x value and a y value. So really all I have to do is transfer that into here. So 0 goes with the y value of 14, 2 goes with the y value of 896. Now it is a table, and you can see I can hit my flag. I know it's exponential because the question tells me it's exponential. This, by the way, would not be enough points to decide what it is. So the question telling you it's exponential is what you would go with. So exponential, zoom fit, make sure you see it goes through the 2 points, but honestly anything would, because it's only 2 points. It's not enough points to decide. So here's my exponential equation, and it's just that easy. So if you can make it a table, you can click the flag, and you will see, and choose exponential regression, and you will see the exponential equation, the exponential function, and then you may begin to answer some questions. For example, a question could be, what time, so I'm just going to answer some questions. At what time is, and I actually don't know, so let's just put this here. At what time would, and at whatever the context of this is, so let's say it's the calories left, the bacteria left in your body, something like that, or the value of a car, the value of a house, whatever. All right, at what time would the y equal 7,168 at 3? And this you'd have to say, is it years, hours, whatever it is, you would say at 3 hours, at 3 weeks, at 3 years. So at what time is it 7,168? You put it in, you hit table, you press enter, enter, enter until you see the y value you're looking for. If I asked you, what is the y value when x is equal to 10? So the same kind of thing. So you'd come 7, press enter, enter, enter. There is 10, and that's what it is. So that's what, 15 billion? And you don't have to learn how to read that. That's something you did in middle school. You can just copy this verbatim. I will give you full credit. All right, so that's how we can start to apply some of the questions that you're going to see. Let's practice.